We have two parts in our model. The first part is the gear and the second is the pinion. We have gear 3 and gear 4 in our model. Let's go first to assembly to see the assembly of two gears in our model. As you can see here, we have two parts in the right position in the assembly of our model. Now let's go to property and assign, create material and assign section to the parts. Put steel material. Let's add an elastic behavior to our material. We will use the megapascal as the unit of stresses, and also we have the millimeter in the unit of dimensions. Let's create section, steel section, continue, select steel material, okay, and let's assign this section to our parts, the first part and the second. Now we have the right assembly. Let's go to create step, and we will use the static analysis step with nonlinear geometry set as set on, and with incrementation equal to 0.101. Click OK. Now let's go to interaction. But before we go to the interaction, let's go to parts again and create the reference point to each part. Select reference point for this part and also create another one. Select create reference point for this part. Let's go to interaction. And for this step, let's create coupling constraint, coupling between reference point and their part. Select the constraint control point. Select reference point for this part and click done, and select surface and select these faces for the control zone. And we have kinematic type coupling with constrained degree of freedom. All degree of freedom are constrained with this point. Click OK. Let's add and create the second coupling. Into coupling, continue, select control point, click on select surface, and select surface to control, and okay. Now we have two coupling. This point we need to apply the boundary condition and apply rotational force. Now let's go to create the interaction property between two parts. We will use the tangential behavior with penalty option with coefficient of friction equal to 0.3. Click OK. Now let's use the tool find contact pairs to find the contacts in our assembly. To find the contact zone in our assembly, let's use the angle with 90 degree and tolerance with this value. Let's find contact pairs, and as you can see here, we have these contacts in find in this position between all surfaces in our first gear and all surfaces in the second gear. You can change this value to 50 degrees and to see we have many contacts, but for this value we found all surfaces in one contact interaction. Click OK. Now, as you can see here, we have our contacts created in our assembly. Now, let's go to apply boundary condition, and in the initial step, we will apply displacement rotation for the first gear and avoid translation and rotation in all directions. Also in the second gear, avoid the translation and rotation in all directions. But let's go to the step 1 and edit the boundary condition. For the first gear, we have rotation around z-axis. Let's go to this value and add rotation, for example 0.5 radian per second, 0.5 radian. Click OK. And also in the boundary condition for the second gear, let's allow the rotation around z-axis. For this boundary condition, that means when we have rotation for this gear with 0.5 radian, this gear also rotates with this gear. Now let's go to the mesh module and let's mesh with in the assembly. Let's go to the instance, make dependent. To make assembly for these two instances in one, in the assembly, let's go to assign mesh control, select two instances, use tetraeder element, okay. And now let's use the mesh by edges and select this zone to simplify to make our mesh finer in this zone, for example 1 mm in the size, okay. And in then another zone, let's use the size more than, or let's use 3 mm. Click done and let's mesh our assembly. As you can see here, we have the mesh finer in the zone of contact, but less and rough in the other zone. Now, let's convert the mesh to linear elements. And now let's go to the job and create analysis step. submit. We have completed job. Let's go to the result and let's see the plot the rotation. As you can see here, you can see the rotation of the first gear and the rotation transfer to the second gear. Let's hide the unnecessary edges. Let's also plot the stresses in our assembly. And you can see the stress in the contacts between two gears. You can change the or add the angle of rotation by increasing the value of the radian. Let's go to the first. For example, let's do 1 or 2 radian per second, 2 radian as the angle of rotation. Click OK and rerun again the job and we can see the result. For example, create 3 or 3. Continue. OK, and submit the second job and let's see the result. For the second configuration, we have these results and you can see our rotation of our gears. And now let's see the stresses and strain in teeth of our gears. This is the maximum stress in our model. Let's hide unnecessary edges. And also you can go step by step or frame by frame to see the stresses and in which frame we have strain and stress. You can see the zone when we have the maximum stress in our gear. And so now I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you.